Yeah, good evening all. So before I start, can one please confirm whether my voice is clear, right?
It's clear, sir.
So what is Databricks? What is Azure Databricks, right? So providing a Spark cluster. Spark is an execution model for processing huge data. So the main feature like in-memory computation provides a massive parallel processing, right? Lazy evolution, whenever you perform any action, then only the data flow is going to execute from its root to this, right? And persistence means already executed a transformation. You can reuse, no need to re-execute, right? From the beginning of it. Partitioning, total the data objects.
In memory meaning it works on the RAM.
Yeah, memory level storage, memory level processing, right? So as compared to that disk processing, that's the reason it is 100 times faster. Means in memory means memory level storing and memory level processing. Means this is Spark data objects. They'll be divided into smaller partitions. The partitions will be distributed across multiple RAMs of multiple worker nodes. See, you have got a cluster, right? In Spark means multiple slave nodes, worker nodes will be there. Means your data will be distributed, means stored across multiple RAMs of multiple worker nodes. Means if your data object is a bigger data object, means Spark generally we are going to process bigger data objects, right? The bigger data objects, it's going to be divided into smaller parts called partitions. That partitions are stored across multiple RAMs of multiple worker nodes and are processed parallelly. Parallel processing you are going to see. That's why that we call it as in-memory computation, because of which it is 100 times faster than the normal disk processing, right? Here, one thing you need to understand here, the processing of Spark, right? So in Databricks, you see the execution is Spark execution model. Here, you may ask, you may get multiple queries, right? Here, it's a cluster means a group of nodes connected in a network. Group of nodes connected in a network in this way, right? S1, S2, slave 1, slave 2, slave 3, in this way, slave n, right? If you have got any data object is divided into smaller parts. Each part stored across this multiple RAMs of multiple worker nodes. They are processed parallelly. Storing within the RAM, processing within the RAM. For example, storing within the RAM and processing within the RAM, right? So for example, here the basic entities of Spark we call like ODD. The basic entity of Spark we call like ODD, right? Later, currently we'll be working with the data frames. Mostly used are data frames, but uh, resilient distributed data sets, we say. Resilient distributed data sets. So these will be divided into smaller partitions. They are going to be stored across multiple RAMs of multiple worker nodes and are processed parallel. Here, one thing is RDD1, the output of this is the input to the next one, RDD2. So Spark data objects we call as RTD, data frames. Later, like with schema, we call it as data frames. The output of this is the input to the next. The output of one will be the input of this, RDD3, RDD4. Now try to answer. This is the final output. Will all these RTDs execute parallelly or sequentially? I want the sessions to be interactive. Right, everyone try to.
Sequentially.
Will this be executed sequentially or parallelly? The Spark sequentially, right? Because the output of one is the input to the next. Where this 4 RTDs will be stored? where this means RTD in Spark data objects is called as RTD, where these RTDs are stored. Where the RTDs are stored.
RAM in memory.
In memory means in the RAM it has to be stored, right? Yes. But a single RTD, it's a bigger data value. It's got bigger data value. If your if your data flow has got 20 RTDs, one RTD already is a bigger data value. But if 20 RTDs are there, 20 RTDs, is it will they be accommodated in the RAM? 20 RTDs means
No.
a bigger data value, right? 20 RTDs can be stored at a time into a RAM?
No.
No. How it is going to be stored? First RTD1 gets loaded. Understand here, RTD1 gets loaded. RTD1 is going to be divided into partitions. See, RTDs won't execute parallelly. They are going to be executed one after the other. It is divided into P1, P2, P3, P4 partitions. P1 stored in system 1, P2 in system 2, P3 in system 3, P4. These are going to be executed parallel. This particular RTD means this data object divided into multiple parts, the multiple parts stored across multiple systems and executed parallelly. That output is given as input by the second one. The second one. Once this RTD2 gets the input from this RTD1, and once RTD2 is loaded and ready in the RAM, RTD1 gets removed from the RAM. Understand here, RTD1 gets removed from the RAM. Now,
So how will these RTDs get formed?
see, when RTDs gets formed means whenever you load some data, whenever you are loading some data using the Spark context, loading a file, whenever you are loading a file, these RTDs are created. Whenever you load a file by default using Spark context, then this RTD created. First RTD created. From the first RTD, from RTD1, if I perform any operation, some mapping operation, map operation, or flat map operation, or RTD1 dot filter operation, or grouping operation, some operation, whatever you are, if you perform any transformation on a particular RTD, the resultant also is an RTD. How RTD2 got created? From RTD1. RTD1 dot filter, RTD2 got created. Again, an RTD2, if you perform some kind of a transformation, inbuilt transformations are available. On RTD2, if you perform some kind of operation, okay, RTD3 gets created. Again, on RTD3, if you perform something, some transformations only, then RTD4 gets created. So in RTD1, think that you have got some 10 lakh records data. And that after filtering operation in RTD2, think that you got some 5 lakhs only. Means nearly 5 lakhs got filtered. Means all the RTDs won't have the same data. We are performing some transformation. Here map transformation is there. In the map transformation, you are mapping some logic. You are mapping some logic for each and every record. For each and every record, the logic has to be applied. What is that logic? For map, each and every employee salary add 5,000. To every salary add 5,000. That is my logic. That should be mapped to each and every record. Means every record, 10 lakh records are there. For all the 10 lakh records, increment or some bonus to be given of 5,000. Means that is map. So from that, there is one transformation, filter transformation, grouping, or any other transformations, right? So first RTD1, how it was created means loading the data from a file. from a, okay, that RDD1 gets created. Once it is created, from that all the things RDD2, RDD3, RDD4 flow gets created. The flow will be, the output of one will be the input. The output of this will be the input. The output of this will be the input. So here what I mean, when RTD2 is ready and it is loaded and computed, it's loaded and computed. Okay, you got the output. RTD1 gets removed from the RAM. Because if you load all these RTDs into the RAM, right? At a point of time, it cannot accommodate the new RTDs. Because the RAM totally will be occupied with this. So whenever this is loaded, computed, now this is not required. Now you already collected the output of it. Now it is not required. It will get removed automatically. And when this is ready,
So you mean like active RDD will be consuming memory and the previous
Ah.
one will be removed from memory.
removed will be from the.
Okay.
If you have got a very big flow, like 20 are there, all that, whenever you are processing RTD 20, do you think all the previous 19 RTDs won't be in the RAM? Collecting the output and removing.
So what about the already processed RDD? They will be stored in the disk space somewhere and active one will be in the RAM.
See, okay, 1 second. I'll show you one flow. 1 second. Observe this flow. R1 is there. R2. R3. From R3, R4, R5, R6, R7, R8, R9. R1, R2, R3, R4, R7, R1, R2, R3, R5, R8, R1, R2, R3, R6, R9. So here totally, this entire thing we call it like flow 1. This we call it like flow 2. This we call it like flow 3. Flow 3 flows are there. Flow 1, flow 2, and flow 3. 3 flows. Try to say me the flow 1, which are the RTDs which are involved in the flow 1. R1, R2. Means you are getting 3 different outputs here. This is giving one output. This gives one output. This is giving one output. R1, R2, R3, R4, R7. Flow 2. R1, R2, R3, R5, R8. In flow 3, R1, R2, R3, R6, R9. 3 flows are there. I want to execute the first flow. If I want to execute some flow, right? Generally, lazy evaluated. These are lazy evaluated, right? I'm saying lazy evolution. Lazy evolution and active evolution. Active evolution means immediately on declaring, executing is what? Active evolution. Lazy evolution means whenever you perform some action on that, then only the flow executes from that R1 to that particular RTD. So you perform some action executing flow 1. Flow 1 I'm trying to execute. Check this flow 1. If I want to execute this flow 1, I need to perform on this R7 dot action. Some action you perform. Once you perform R7 dot action, it will start from this root RTD. If you perform on R4, if you perform action, the flow will start from R1 to R4 and R4 output will be collected. If you are performing action on R7, from R1 to R7, the flow executes and R7 output will be collected. So here first R1, from that R1, you perform some transformation, R2 got created. The output of R1 will be the input to R2. When R2 is loaded, computed and ready, the total R1 is going to be removed from the RAM. From R2, R3, R3 is ready, loaded, computed. Slowly this R2 gets removed from the RAM. From R3 again R4 loads, computes, ready. R3 gets removed, the previous one. Now R7 loaded, computed and ready, and this is removed. Once this output is collected, once this R7 output is collected, final output is R7, its output is collected. Now this is also going to get removed from the RAM automatically. Now the flow 1 executed, the output is collected. Now try to say me how many RTDs in the RAM now? How many RTDs in the RAM? No RTD in the RAM? No RTD in the RAM now? Now you can trigger the second flow. You will be triggering the second flow now. Now again the second flow totally RTD by RTD. See that R1, R2, R3. Here you need to understand three things. At the end of this flow, I will show you what are the three things you need to understand. R5, R8. This is your flow. Means R1 output is given to R2, R2 output is given as input to R3, R3 to R5, R5 to R8. When R2 is ready and computed, first R1 and its partitions, everything will be loaded across the RAMs and are processed parallelly, and this output will be given. Output is collected, and a new R2 is created. When this is loaded,
So in flow 1 itself, we already got R3, which is common, right?
yeah,
So,
understood your query. Why can't you use the R3 output you are asking, right?
mhm.
I'm coming to that. So here I cannot use R3 out. You are asking, yes, good query, right? R1, R2, R3. In flow 1 itself, R3 is executed and R3 output. Why can't you use again? Why you are executing R1, R2, R3? Understood the query? Already R3 is executed. R3 output. Why can't you use R3 output? Again, why are you executing R1,
different
R2?
outputs, right? Here.
So, okay, but R1, R2, R3 are already executed.
R1, R2, R3 is a common data is available.
Yes.
From R3 is a divide the data, 3 flows.
Yes, yes. But R just at the end of the flow, if you observe, right, no RTD in the RAM. Nothing is
Okay.
there in the RAM.
Okay, you are telling is that R7 is there, R7 output. R1 is the out. R1 is in, R1, R7 is in, R1 is out, right? So R3 up to R3 is maintaining the data, common data.
Yes.
R1, R2, R3.
Hmm.
From R3 to R4, R7, R5 to R8, this is a different data.
Yes.
Here we are using the filter condition.
So whatever transformation you are applying, whatever, see how you got this R4, how you got this R4, R5 means you applied some transformation.
Okay.
Some transformation you have applied. You got that R4, you got this R5. How you got this from R3, how this R5 is got means on this R3, this data, you applied some transformation, you got R4. Again on this R3, you applied some transformation, you got R5. On this R3, again you got R6. For example,
Okay,
if you
for
got,
example,
if you-
okay,
for
sir.
example,
Okay, go ahead.
this is min cell, this is max cell, this is sum of cell. Assume on this R3 you apply, right? So three different operations were applying.
Hmm.
But first flow executed. First flow already executed. But
Go ahead, sir. Go ahead.
but okay, the first flow already executed, but finally, okay, you got the output. You are expecting the R7 output. R7 output is collected. Now, no RTD is in the RAM. After executing the flow 1, all the RTDs one by one they loaded, one by one they computed, one finally you got the output. Now finally, or they got removed. Now the total RAMs are free now. Now you are triggering the second flow. In the second flow, what happening? You are just saying to execute this R8 dot action. Whenever you say R8 dot action, what immediately it does is where I need to start the flow from. It will check where this flow has to be started from. Immediately it is going to check. Means it will check. Okay, R5 is available. No.
Not available.
R3 is available. No. R2 available, R1, nothing is available in the RAM, right?
R3 is available.
See, when R4 got ready and computed, R3 removed from the RAM as well. When R4 loaded,
Sir,
computed,
Okay,
the
sir.
previous,
The
the
R3,
previous,
what about the R3, sir? R3 is having the common data,
no,
min
no,
data,
no, one
max
second,
data, some data.
one second, Ravi.
Okay.
First, one second. Flow 1, flow 2, flow 3. After completing these 3 flows, right, you can ask your query. You will get that solution for that. I'll complete this flow 1, flow 2, and flow 3. You will get the total idea what I am trying to say, right? So observe this flow 2 and flow 3 and come back. I'll come back to your queries. Flow 2. In flow 2 also, just try to observe whenever I am saying R8 dot action. See, R8 dot action, if we say the flow is going to execute from the root RTD, again it is going to start from R1, R2, R3, R5, R8. So first R1 loads the partitions, computes parallelly. The output will be given to R2. When R2 is loaded and computed, the previous RTD gets removed from the RAM. And now this R2 output is collected by R3. Now R3 is loaded into the RAM. It gets computed. Now it is ready. Now when it is computed, it's ready. This previous one is going to get removed from the RAM. Now R5 loaded. Now observe here, R5 loaded into RAM, taking the output of R3 as input. This R5 gets loaded in its partitions, computed. Now I'm saying R3 removed from the RAM. Now, okay, R5 is computed, it output taken by R8, R8 loaded, computed, the previous one gets removed. Now R8 output is collected. Now R8 output is collected. Now once this R output is collected, immediately this also gets removed from the RAM. Now I'm saying there is no RTD in the RAM. Now see the last flow in flow 1, flow 2, flow 3. To execute this flow 3, what I need to say? R9 dot action. Means R9 dot action, if you're performing action on R9, right? So the flow executes from R1, R2, R3, R6, R9. The flow executes from this. Now, when R2, R1 first loads, computes, its output will be given to R2. Now R2 loads, computes. Now when it is ready, this is going to get removed. Now R2 output is taken as input by R3, loads, computes, and this previous one is going to get removed. Now this R6 loads, computes, and this R3 gets removed. When this is loaded, this is going to get removed. Finally, R9 output is collected and output is collected. Even after that, this R9 also removed. No RTD in the RAM. No RTD in the RAM. Means what you did here, you 3 flows you executed. Every time you got the output. First flow output, second flow output, the third flow output is collected, right? And what happened each time? The RTDs one by one, they are loaded. If there are 50 RTDs at a time, they won't be loaded. One by one, they are going to be loaded. At a point of time when the 50th RTD is loaded, all the remaining 49 RTDs won't be in the RAM. That much of RTDs can't be accommodated into the RAM. So what happens? The previous everything one by one, it is going to get removed. Finally, when it comes to the 50th RTD, last RTD, when its output is collected, that also gets removed. Now no RTD is there. Now you can execute the next flow if you want to execute triggering the next flow. Now in this, there is one drawback. In this, you can see one drawback. Yes, as just now that Ravi was asking, right? The drawback is in all the flows, if you see, all the flows, if you observe flow 1, flow 2, flow 3, these are common. First 3 steps are common in all the 3. First 3 steps are common in all the executions. And he was asking, right? When the first flow executed, this R3 also output you got, the R3 output also you got, right? I said a feature just now, right? What is that? Persist persistence. Spark feature is what? Persistence. Lazy evaluated. Massive parallel processing. Massive parallel process in memory computation. In memory means with the RAM level. So multiple partitions stored across multiple systems running parallelly. Whenever I perform any action only, then it will execute. Otherwise, don't execute. This persistence you need to understand the feature. Important feature of Spark is means. Now observe this flow now. Why you are executing the three already flow one executed again in flow two? Why you are re-executing this first three steps? Already in the flow one they got executed. I said, why can't you make use of the output of R3 already executed transformation output? Why you are not able to reuse here? In Spark, we have got a feature, right? We can reuse already executed transformation. Already don't execute these three directly from R5 and R8 you execute by taking the output from this R3. But to take output from the R3, this R3 is not available in the RAM. It got deleted. So for that purpose, what you do is anytime in a flow, any RTD's output is used by multiple flows. Any RTD's output is commonly used by multiple flows. Persist it. Persist it. How will you persist? R3 dot persist, you will say. What do you mean by this option? R3 dot persist means making the RTD available in the RAM. Even though the next RTDs are ready, are computed, that R3. Make this RTD available in the RAM permanently. Don't remove from the RAM, because it is the RTD which is providing the output to multiple flows. For this first flow, it is providing the output. Second flow, third flow, it is providing the output. So if I am persisting this, means it is not persisting enough RTD means making the RTD available in the RAM, even though the next RTDs are ready, is not going to be deleted. For example, now this is the flow I said R1. Now see the flow, how it is going to get decreased. R4, R5, R6, R7, R8, R9. This is the flow. This is persisted. This is persisted. Okay. Flow 1 to be executed. Understand here. Flow 1 to be executed. First flow compulsory. Whenever I say R7 dot action. Whenever you say action on this.
How will we know how many RDBs it's forming? Normally we'll not be knowing, right? So we will only give the input as data and output will get it in the filtered or something like that.
See here,
Well,
how are you going to write the code? R1 equal to some file you are loading. You are loading.
okay.
R2 equal to R1 dot R1 I'm using that R1 output time. So this R2 is not present. R1 dot map with some logic. Some logic. That logic you mapped it. After mapping this, the result whatever you get is nothing but R2.
Okay.
So the result of an RTD is an RTD.
Okay.
R2 you got. Again an R2, I doesn't want to perform filter only the particular filter, only city equal to Hyderabad. Some condition. Means in R3 only the particular city data only available. On that again, entire city I doesn't want. Particular department of that city only, like marketing department. Again like R3 dot filter, again some department number 11 only I want. R4 you got. Again from R4 some activity, grouping activity or any other activity you have performed. R5 you got. Means in this way you will define. Finally, okay, you want R5 dot R6 output I want. This is my final output I am collecting. means loading, next performing some kind of transformation, after that filtering, otherwise next merging, something you do. Finally, you are writing this code. You are writing this code. What the transformation you want to perform, right?
Okay.
You are writing the code. Here you will come to know, okay, this output is this output is this output is this. You came to know how many you have defined, 6. Now what happens here, where there all the 6 won't be loaded at a time, because one by one they gets load, one by one output will be given as input. When this R2 is ready, will be removed. When R3 is ready, collected the output, R2 gets removed. In this way, it is going to be done. Now, in this coming to this flow, right? Yes. Now observe carefully here. Persistence. One more important feature of Spark is persistence. What is this persistence? To understand, whenever you perform any action only, this R1 to R7 gets executed and output you can collect it. Until then, they won't execute. That is what lazy evolution. In this R7 dot, the flow executes R1, R2, R3, R4, R7 in this way, right? It is going to get executed in this manner. The output of one will be the input to the next flows, right? So one by one, they get loaded, computed, loaded and computed. But here, when R2 is ready, R1 is going to get removed. When R3 is ready, R2 is going to get removed. And now R3 is loaded and computed. Now when R4 is ready, do you think R3 removed? Hello? Will R3 be removed? I said persist.
No.
Said persist, right? I said persist. Whenever I say persist, it should be available. Even though next one is ready, it won't be removed. Next, when R7 is ready, this is going to get removed. When this final output is collected, this also got removed. Means you got the output. Output is collected. But what is there? What is available in the RAM? R3 in the RAM. R3 in the RAM. Okay, for the first flow, okay. But whenever you are executing the flow 2, whenever you are executing this flow 2, right? Understand what is the drawback we have observed in the previous flow is, even though the first 3 steps are common in each flow, again, every time it is re-executing from the beginning. In flow 2, in flow 3, re-executing from the beginning. So instead of that, what I did, I persisted R3, whose output is used by multiple flows. Now, if I say this R8 output you are expecting, R8 dot some action you will be performing. If you are performing that, where that the flow has to be started? Where the flow has to be started? How it is going to be computed means
R3, sir. R3.
first it will check R8. Input is R5 is our next. R5 available in the RAM. R5 available in the RAM. Hello. So first
No.
R8 dot action means
R5 is
what it will think first, what it is going to come. First it will check to execute this R8 and to get the output of R8. First the input, you need to get the input from R5. But R5 is not available in the RAM. Again, so again it will check for R5, which is the input for R5. R3. R3 available in the RAM.
Yes.
Let's see R3 in the RAM after the first. Now the flow is already R3 available in the RAM. So it is ready to provide its output to R5. It collects that R5. This is the flow. No need to execute the first 2. 1, 2, 3. R1, R2, R3. No need to execute. I'm saying.
So, so Vijay, what's the difference between caching and persisting here? Because even persisting here is on RAM only, right? Generally, persisting means it goes back to the persistence database or whatsoever. But what's the difference?
So
Yeah.
difference between persisting and catching is, persistence will make use of all the options. Persistence will make use of all the options. Means all the options means catching will make use of only this RAM option. See, persist, we have got many persist options. Many persist option means RAM only option is there.
Okay.
Memory only option, not RAM only. Memory only option is there. Disk only is option is there. Memory and disk option is there. Memory option, disk option, memory and disk. Means
So what's the difference between
one
these
sec.
three?
let me complete. See, whenever you are persisting memory only, whenever you are persisting, right, memory only. For example, whenever you are persisting, for example, R3 dot persist, you are saying a particular RTD, you are persisting. Whenever it is getting, what happens is RAM space is totally busy executing the other RTD. Some other flows are executing, but totally RAM space is utilized by that. But to load this, there is not sufficient space available in the RAM. If available, okay, directly in memory only, you persist. In such case, your flow is going, it is going to fail, right? When it is going to be failed, if sufficient memory not available to persist this, it is going to be failed. Then here, memory and disk option, if you are providing, where you will provide this here as a parameter to this. Where you will provide this as a parameter to this persist. Memory and disk only if you are giving this option, if memory available in the memory, it will persist. If this memory is not available in the disk, it is going to persist. Understand here? Memory and disk means if memory available in the memory, otherwise don't fail. Instead of failing this, right, it will be persisted in the disk. But if you are giving this option here, if memory not available, it is going to fail. Because of this memory issue.
So usually,
it is not going to. So in such case, you will give memory and disk option. And if that what if this is very big, right? It cannot be accommodated at all into the RAM. Even if total all the flow executions are completed, no other flows are using your RAM, but still, then you can go for disk only option, memory only option, memory and disk only option. This is persist will make use of all these three options, but there is one more called cache, as you said, cache, right? So you can make use of only memory option only. The other options you want to get for it.
memory as in RAM.
Only in the memory, yes, in the only that option. You won't get the disk only and memory and disk option. You want to get it for it.
Okay.
So if coming to this, coming to our flow, right here, you are executing only R5 and R8 because R3 already available in the RAM. You are making its output, collecting its output, and just computing the other flow, right? That is means you are not re-executing again. You are taking the output of already executed transformation and just continuing the remaining part of the flow. Even similarly, if I take
default option of persist, what is the option of persist?
Default option of persist, see, default means memory only.
Memory only. Okay, cache is also memory only.
Yes. Flow 3, right? Flow 3, if I am saying I want R9 dot action, many actions are there. Collect is one action, count is one action, take is one action, save is one action. In this way, any action if you are applying, right, then the flow executes. Whenever you are expecting the output of R9, first R9, it will check from where I need to get the input from. For R9, which is that? R. For R9, what is the input to R9?
R6.
R6. R6, is it available to give its output to R9?
No.
Not available. Now it will check. Then next execute from R6 input is
R3.
R3. R3 available in the RAM.
Yes.
Yes.
Whenever this flow executed, when R8, R5 removed, when the output is collected, this also got removed. R3 in the RAM. R3 in the RAM. Here also R3 in the RAM. Now here R6 input is R3. R3 is available. R3 is ready to provide its output. So the flow is, now you got the flow is R3 and this R3 to R6, R6 to R9. Now, R3 will be available in the RAM, R6, R9. When R9 is ready and computed, R6 gets removed. When R9 output is collected, this also gets removed. Here also R3 in the RAM. Means here output you got the output for all this. Means here no need to execute the first 3 steps in the flow 2 and flow 3, right? Already executed transformation output. It is taking and computing the remaining flow. Every time it is not re-executing. If the same steps are there, right, you can make use of R3. Means anytime which RTD you are going to persist means the RTD whose output is commonly used by multiple flows. That if you persist, then what happens? It will be available in the RAM. It gives output to the multiple flows.
So why don't we use cache? Because it's also memory only, right? By default, persist is also memory only. Why can't we use cache by default to save that in transformation?
So okay, so if you want to persist an RTD, 2 methods are there: persist method and cache method. Cache, anything you can use, both R3.persist or R3.cache. But what happens in this case? Whenever the other flows are executing, now you are just saying R3.cache when this statement executes, right? But all the other flows are utilizing your RAM. There is no space here to persist it. It gets failed here. You are not having that option like a disk option here. In the persist, you have got that option. If well, RAM available in RAM use, otherwise in the disk.
But we have to specify memory underscore disk only.
Here in the persist, you can use that. In cache, you cannot use. Only one option you can use is memory only in the case of cache. Only one option can be used. Here, multiple options, three options are there.
But you're saying that persist by default uses the memory only, sir. So my question is, if it is like memory only, then it is same as the cache, right?
One second.
Then how come?
Just observe here. So 3 options are there. I said memory only, disk only, memory and disk. If you're not providing any option, I'm saying if in this persist, if nothing is provided, default it takes memory only. But specifically, if you are giving this memory and disk, right? Memory and disk, if you are providing, so if memory is not available in the disk, it will be. If you are giving only the memory only, it will be persisted. But in the case of cache, right, only this one option only can be provided, I'm saying. Only that one option only it is. There's like disk only and memory and disk only option is not available for it.
So
That's
any other difference between, let's say, timeout or something like that between a cache and persist?
No.
Okay, the same time. Okay.
Persist, these two are the 2 methods for persisting and RTD, both can be used. But persist will make use of all the options, but cache only one option, right? It cannot be persisted in the disk. We are using this option.
Okay.
See, if it is persisted in the disk also, right? Okay. For example, okay.
So RDD is a massive parallel processing, sir. So massive parallel processing in the sense it's stored by default in the RAM, not in the disk.
For example, observe this. Observe here. System 1, system 2, system 3. Two TB, 2 TB, 2 TB. Assume that you are maintaining this RAM capacity. Total RAM capacity 6 TB. R1 size is RTD1 3 TB. R2 3 TB. R3 8 TB. R4 3 TB. R5 3 TB. Try to say no. Loads into RAM means this cannot be loaded, right? This can't be loaded into the RAM. Disk, it will be in the disk. R4 going to collect the output from the disk and loads into RAM. R4 collects the output from the disk and loads into RAM. And again, this 3 TB in the RAM, in the RAM, in the RAM. All this will be in the RAM. That is
So in
what.
that case, sir, R2 dot persist, then we have to give R3 dot persist. In the option, you have to give memory underscore disk only.
Yeah, memory disk only we need to give.
Then how can we know that R3 is 8 dB, R2 3 dB? Like,
See, for
Um,
example, from 3 dB, 8 dB is generated. R2 output is input to R3.
so will you provide live examples in future, sir, for this
Yes,
one?
yes. It
Yes,
means
thank you.
huge data is generated by this for this. The output of R2, the output of this is input to this. So many records are generated from this. Okay. So here coming to our flow, right? So here no need to execute from the beginning. You can just from the persist. That is what the feature persistence. One of the important feature of Spark. Persistence means already execute. For example, you may, if you take a bigger flow, you will get understand much better, right? From R1, R2, R40. From R40, the flow is like this. Flow is like this. From R40, it is like this. R70, R80, R90. Means in all the flows, right? First 40 steps are common. In all the 3 flows, first 40 steps are common, right? Flow 1 you executed. Flow 1 executed. Flow 2 you are trying to execute now. Flow 2 you are trying to execute. This you have persisted. No need to execute from 40 steps decreased, right? 40 steps directly your flow will be from R40 to this. First 40 steps you no need to execute. Similarly for flow 3 also. R40 to R90. First 40 steps you cannot. No need to re-execute already. So already R40 is available in the RAM. Its output you can take and just to go with this flow. R90 also, right? You can take it and execute.
So till when R40 will be available, even if all the flows are completed, still it will be available?
Yes, good question. Right, 1 second. Here total flows are executed. See our flow. Here flow 2 executed, flow 3 executed. This is your flow, R3 in the RAM, R3 in the RAM, R3 in the RAM. In all the 3 flows, R3 available in the RAM. So finally, if your R3 is not required now, total execution completed, output is collected, now R3 is not required. Forcefully unpersist it. Forcefully unpersist it. Forcefully unpersist it by saying R3 dot unpersist. It will be removed from the RAM immediately. Immediately, I'm saying this unpersistence will happen immediately, but persistence won't happen immediately. Persistence won't happen immediately. Why? Anyone? Why? Unpersistence happens immediately. It will go and remove this R3 from the RAM. But persistence won't happen immediately. Why?
Because persist is a transformation and persist is a action.
No, not that. Observe here one more question. When a RTD get persisted, when a particular RTD gets persisted means simple answer. When first time it is loaded into RAM, it gets persisted. Means if this is your flow, this is your flow. R40 you want to persist. R40 you want to persist. R40 you want to persist means directly, immediately you cannot load R40 into the RAM and persist it, right? Until this first 39 RTD is loaded, First 39 RTDs has to be loaded. The 39th RTD output should be taken, then R40 has to be loaded. Until then, this won't be persisted. Once first time R40 loaded into the RAM, it gets persisted. Understand here, when RTD gets persisted means it happens during this process. During the process means first R1, R2, R3, R4, R5. Now when R40 is getting loaded now R40 is getting loaded. When R40 is loaded, immediately that gets persisted. And during the flow execution only it happens. But whenever you say this entire flow, now in all the first flow, second flow, third flow, R40 is available in the RAM. Which RTD is available? Only one RTD is available in the RAM, that is R40. Immediately, if you say R40 dot unpersist, it immediately removes that particular RTD from the RAM. That it immediately happens. But persist won't happen immediately. When it happens, once you trigger the flow, once the flow executed, one by one, once it comes to 40th RTD, that RTD is loaded into the RAM. Now it gets persisted. That is persisted happens only when RTD first time gets loaded. When first time gets loaded. Understood, right? So features of Spark, first is in-memory computation, loading within the RAM level, and processing within the RAM level. That is the first one. Second is massive parallel process. Spark is getting high speed because within the memory level processing and also parallel processing, your particular RTD partitions are distributed across multiple RAMs and are processed parallelly. Lazy evolution, right? Means when just like whenever you define in programming languages, you see, whenever you define a function, but if you're not calling it, there is no use of defining that function, right? Means whenever you call the function only, it executes. Until then, no. Means any number of times, how many number of times you can call it. Here also, whenever you make an action only, that total flow executes. And persistence means, just now I said, you have got many rules to be followed for persistence. They have got many rules are there. If you want to use already executed transformation, at least one flow should be executed or not. Whenever the first flow is executed only, you can make it from second flow and third flows, they can reuse it. Immediately first flow can't reuse this R3 output. First flow executed, now R3 loaded, persisted. Second flow and third flow, they are reusing this R3 output. So at least one flow has to be executed to make use of it. Okay, and what is the other one? Partitioning. Spark has got the capability of controlling the parallel processing. Spark has got the capability of controlling the parallel processing. Can control, it can increase the parallel processing. So depending upon the partitions, whatever you are specifying, those many partitions gets created and parallel processing. So here, that's the reason Spark 100 times faster than normal disk processing, right? So that is the main features in memory computation, persistence, MMP. It is not MMP, sorry, it is MPP, right? Massive parallel process. So this is what we have understood, right? Just I was showing you some flows, right? So the mainly RTDs and our RTDs doesn't have schema, but today data frames are mostly used. RTD with the schema, we call it as data frames. Data frames means you will get some tabular structure with columns and rows. So the main feature of this Spark data frames, many data frame APIs, there are many functions, many built-in functions provided by using that we can. And also Spark has got libraries which includes pure SQL kind of querying you want, you can perform. And like other important features like it has got many libraries. People means who go for data science environment, right? Like even if they can make use of Spark, it has got many libraries towards machine learning, right? It has got many and it has got many functions it is providing to this machine learning, and also it is providing streaming kind of activities also, right? It has got uh, the micro batching, we say micro batching. For every 5 seconds I want some updates, every 5 seconds I want updates. Those kind of things you can achieve by using Spark. So here, as I said yesterday, Spark has got multiple languages support. Currently mostly used language is Python. Python is the language of implementing, right? So Spark implemented by using Python. It can also be implemented using other language like Scala. In the industry, right? Mostly Python and Scala are mostly used. Previously, Scala was used a lot. Scala language is mostly used. Talk about 2015, 16, 17, 18. Only Scala was used a lot for Spark. But later, it started using Python for Spark, where Python has got many functionalities towards this advanced analytics. And even languages like R language also can be used, but there is no implementations, right? The industry on this Spark with R language, Spark with Java language. Spark with Java, Spark can also be implemented using Java, but we are not using the Java, but huge codings, lot of codings involved in Java. Already you know, Java means huge codings will be there, fine? So here we are going to discuss each and everything in brief by using this Azure Databricks, where it is providing the cluster, right, for executing this Spark. So this Azure Databricks with the PySpark, everything will be dealing in brief, step by step. We'll be learning, right? From the next week onwards, we are going to start with this, right?
Even Spark is also tough, right?
Spark, if you understand the functionality and if you are going to work, right, it looks very simple and easy if you understand that things. Right?
Because in the company that I had worked before, they used Spark coding and for data processing, and it's a very huge code with 5,000 or 10,000 lines, and it was difficult for me to understand there. So
they used Scala or Python?
Scala.
Scala will be the coding will be there. Scala means a scalable language, like it's extension to Java language. But
it's huge code actually. It's I could not understand that.
So Scala, okay, you'll be having coding, right? So here, observe this. I said Spark can be coded with Scala language, Python language, Java language. So Java not at all preferred. I said previously in the industry they used, I said like especially in the year when implementations of Spark 2015, 16, 17, 18, up to 18 and even 19, Scala was running in the industry. Only people used to, only they were batches, right? I also used to take batches like the Spark and Scala batches, right? Only Spark, but now I'm not taking any Spark, and Spark with the Python batches, PySpark batches are available. But previously, people used to update only with Spark and Scala, Spark with Python. But from last 3 years onwards, 2-3 years onwards, people started with PySpark. But previously, only Spark and Scala, It's a very high boom at that in 2016, 17.
In AWS also, they are everything is programming only. So they wrote a big Spark code and they are calling those from AWS actually. They are writing some codes and calling it with AWS.
So yes. So here Java, Scala, and Python, but Python, PySpark, right? You won't see a lot of codes. Inbuilt functionalities available, right? If that functionality is not available, then you will define your own function and you will write the code, right? If any function available, right? Data frames providing lot of functionalities. If that functionalities you can make use. If that functionality not available, then you will define your own user defined functions, right? And you will write the code for it. Okay. Fine. So Python plus a Spark. So as part of our course, we are going to use Spark and Python, right? Yes. Any other queries, right? Yes. So
The
from
last,
next
one more
week,
question.
one second, next week we'll be starting with the actual course. So starts at 4 p.m. But next week there'll be a change in the link. So you're supposed to get enrolled if anyone not enrolled for this course, for getting the link to your mail IDs. Next week, a separate WhatsApp group for this Azure Databricks with PySpark, and you'll be getting the videos to your Google Drive, and notes, clear notes will be provided for all this. Yes. Just one
What
second.
about ADE? Already we enrolled for ADE classes, Vijay.
That's what I'm saying. If those who are not enrolled, right?
Okay.
If anyone not enrolled, right? If you got enrolled for ADB, it's ADB is a part of it. Right?
Okay, they will give a link or how it will be?
They'll be providing the link to you.
Okay.
So next by Thursday you'll be getting the link, right? If
Yeah.
anyone, if you're not got, right, by Thursday night, you can just call on these numbers. Right, there are some provided some numbers in the chart, right? You can see a big message given in the chart by the online team. Those you can contact details, you can just store. If you have not got that link, people, if you have already enrolled, right, you can message me directly if you have not got the link, right? If you are for ADB.
Next Saturday is a Vinayak Chaturthi, so do you have the class for that?
Next Saturday is when is it say next Saturday, if it is a festival, right, Vinayak Chaturthi, it will be on Sunday then. We are going to continue on Sunday. Fine. Okay, see that course content is provided, right? In brief, we'll be discussing, right? And you can see that the payment details, everything provided in the chart. If anyone, if you're not enrolled. Yes. So already, if anyone, okay, one second. Azure data engineering, right? So if you want only ADB, 6,000 is the course fee. People enrolled for ADE, or if you want to enroll for ADE also, right? 12K is that course fee. It includes 3 things here in ADE, ADF, ADB, Synapse Analytics, these things. So actually, if you want to go, each one is a 6,000 course, right? 6,000, right? If you're taking as a package, it is 12,000. And if you want to, if anybody still, if you're not got, you can go for this package, ADE package. Go with the Databricks now. Later, if I start any ADF batch, you can attend those ADF and Synapse Analytics batches, right? If you want this package, otherwise ADB with 6K. If you want only ADB.
Synapse is a different batch or how it will be, Vijay?
So multiple batches. Okay, whenever I'm starting any Synapse Analytics, right, I'll be intimating the students, right?
Sure.
Anybody who wants to attend ADF, any ADF batch is starting, I'll be intimating. Any ADB batch is going to start, I'll be intimating them. Means you'll be having WhatsApp group, right? So that's what those who wants to attend parallelly all these things, right? Yes, they can attend. Yeah, some people already attending ADF in the weekdays, ADB in the weekends. That's what. Okay. Fine. So everything will be in brief. Everything will be in clear.
So
and
technically, the batch is starting from next week, right?
yes.
Actually, yeah.
Yes. Yes.
Okay, but
So just yesterday I was just discussing about Databricks and Azure Databricks. What is the difference, right? It is going to provide Spark cluster with auto scaling feature, and also compatible with all Azure storage services, right? Today I was just speaking.
is there any batch like 8 days course or something like where we can attend
8 days course?
like anything like short duration like
Fast track he asking.
fast track? Yes.
No fast track.
But it will won't come that much knowledge in the fast track.
You won't get that much of knowledge, right? Yes.
Yes.
Okay. Separate PySpark batches are available. Only PySpark on premise, right? Not cloud premise. PySpark batch is also available, right? Where it goes for 3 months only PySpark. In brief, in depth, right? Okay, this is ADB with PySpark. Everything will be on the cloud environment.
So what is difference between cloud and this Hadoop?
See, okay, in Hadoop, we have got some components like Hive,
Okay.
Scoop, MapReduce. Cloud, don't say like cloud. Okay, Hadoop is there, Spark is there. Hadoop and Spark both combinedly will be used, right, in the industry, like in on premises. But in cloud premises means you no need to maintain any infrastructure. So master and slave, single master and some 50 slaves are there. Physically, you need to maintain in on premises, right? If
Okay,
you
in
want
Hadoop, you need to physically maintain.
no. Even in Spark also, right? Hadoop or Spark previously, if you are
Yeah.
taking a cloud premises, right, you no need to think about the infrastructure at all, right? About the softwares, about that installations, everything taken by the cloud itself. But on premises, right? On premises means you are physically going to maintain a cluster, just like a lab, right?
Okay.
Like one will be the master, other will be the slaves. In each and every system, we need to install Linux on this top of Linux, Hadoop installation, on that Spark installation, and each and every component installation, and all those things you need to maintain, right? If any issue in that hardware, on the software, everything you need to take care physically, right? But in the cloud, all those are not required. You first thing is it is invisible.
Okay.
The things are invisible to you, right? That's why in the cloud, in the case of cloud, charges will be applied, right? For
Yeah,
that.
yeah.
Okay,
So
but in
Vijay, can we say that for a big data, is it in premise only?
big data, not like that. For big data, both you can have on premise and cloud premise, everything you can.
On premise means inside the office, right?
Which one is more demand, Vijay?
Traditional.
On-prem or
Traditional.
cloud?
So previously, if in the recently, right, if you see from last 2-3 years, everyone they are migrating towards cloud environment.
Yes.
Previously, everything it was on the on premises only. But everything maintaining all this each and every system, these things have to be installed, right?
PySpark is cloud, right?
Databases has to be installed, Hadoop has to be installed, Spark has to be installed, and this softwares like Python or what all the required things, everything has to be installed, and that OS, all this has to be maintained physically, right? So
Yes.
separate, we have got like administrators are available separately. They used to maintain, developers just going to do these things. So now everything in the cloud, it will made simple, right? Just whatever you want, you can perform it accordingly, right? Okay, fine, right? So next week we'll be starting, right? If you'll be intimated, right, through mails. We'll check with that if it's next Saturday, if there is a festival, right? We'll be starting with Sunday. Yes. So if I'm done with your queries, if there are no other queries, I will sign off for now. So this has got a high boom in the market. If you observe this, especially like check with PySpark, right? People, especially PySpark, ADB with PySpark or only PySpark, great demand in the market, and even the salary packages are too high if you talk about this
You
PySpark.
can explain salary structure in this.
So you can check in this Google, check in the Google, right? The salary pack, especially if you check the salary packages, too high packages, but they'll be expecting good technical skills from your side. If you've got good technical skills, definitely you can get through that higher packages. People who will migrate to PySpark expecting huge packages, right? Okay.
Hey, Vijay, one final question. This ADE and this ADB plus PySpark, are they weekend classes or?
This ADB, what I am talking, this is a weekend batch.
And what about ADE? They are.
So ADE, lot of weekday batches are available.
Okay. You don't have weekend for ADE.
ADE, no, I mean, Databricks only available.
Mhm.
And actually, all my Hadoop batches, big data batches, PySpark batches, all are weekend batches. Mostly, I used to take only this. In separate big data batches are there. Hadoop batches, PySpark batches are there, which I'll be taking on the weekend. That's why I'm not going with this ADEs in the most of the
Okay.
batches are weekdays only.
Okay.
Then when everyone is
Okay.
migrating to cloud and everything, then what is the use of Hadoop and these kind? It's not required, right?
People generally, okay, Hadoop and people
Hadoop
they'll
and big data, it's not required, right, anymore because
no,
well,
actually we are running a separate batches for that. People who are interested will go for that.
okay, because there are still companies that are maintaining their own infrastructure.
Some companies, right? Not the big companies like normal other. Some companies are going with that.
Okay.
But slowly, everything will be migrated to the cloud.
Okay.
Right. Yes. Fine. Okay. Now I'm stopping for now. We'll continue, right?
Sir,
You'll
one more
be
question.
yes. Go ahead.
Sir, in this course, like any real-time projects will be also involved?
At the last, I'll be discussing one flow.
Okay.
And
Like a corporate project, how the works are going on, so that we
yes,
can
yes,
will
yes,
help in interviews.
yes. And one thing is you should be everyone should be regular to the sessions and they should do the things practicals and the session should be interactive. You will be understanding much better, right? Very simple and easy. If you are regular to the sessions and if you are practicing the things, right, it will be very simple. Otherwise, if you're missing some 2-3 sessions in the middle and if you're not practicing, it will be too tough to understand the thing, right? Yes.
Yeah.
Okay.
So from most of the time, from the next week onwards, shall we start the practical sessions?
Yes, yes. Next week on is we'll be starting with the practical part and that how to I'll be discussing in the next Sunday, right? About the
Do
thing.
we required any kind of infrastructure to be installed before that?
I'll show you everything, right? It's not a big thing. Then like
If you can tell that advance, right? We can start in case.
Now, if it is on premises means it will be taking time installation. It takes 3 hours, 4 hours like that, but it takes very less time only here. Just won't take much. So step by step, I'll be showing you, right? Where you will, if you want, you can do parallelly along with me. Otherwise, you can do later, right? Next week, I'll be going step by step the things, right? Okay. Okay. We'll continue next Saturday, right? Next Saturday, if it is holiday, right, we'll be continuing on Sunday, right? You'll be getting mails about that class. The timings will be the same, but the link will be changed. Next Saturday, whatever link, right, the same link will be followed up to the end of the course, right? Fine. Thank you all for your time. Thank you. Meet you next week.
Thank you, sir.
Thank you.
Thank you, sir.